Next thing we need to do with natural logs is see how to integrate them. So basically, if we had just 1 over x dx, that would integrate to the ln of the absolute value of x plus c. Reason we need this absolute value of x is really because of the domain of ln. ln doesn't work if you have a negative value for x, or really if you have 0. So by putting this absolute value of x in there, we make sure that you can actually take the ln of it. If we take this concept of how it works for 1 over x and apply it to 1 over u du, this gives us the ln of u plus c. Really, most of our problems are going to be of this type, where we're doing u substitution, and then we go back and replace u at the end and make it ln of whatever function of x it is, plus c. If we look at the first part, part A, here we can just factor out the 10, which is a constant, and turn this into 10, the integral of 1 over x dx. Then we know the integral of 1 over x dx equals the ln of the absolute value of x plus c. So this becomes 10, the ln of the absolute value of x plus c. I could see how you might want to say, well, isn't the 10 being multiplied by the c as well? If you called it 10c, it wouldn't be wrong, but really that c is just a mathematical constant we didn't know previously, so multiplying it by 10 still makes a mathematical constant that we don't know. For part B here, it's a little trickier. I need to start by setting up what my u would be. My u in this case is going to be what's on the bottom, x plus 4. When I take the derivative of that, du equals just dx. So in this case, I'm going to swap out 5 instead of x plus 4. I'm going to change that to u. Instead of dx, I'm going to change that to du. This is the same thing as 5 times the integral of 1 over u du. So it becomes 5, the ln of the absolute value of u plus c. Last thing I have to do is just replace that u with what u stands for, x plus 4. So my final answer is 5, the ln of x plus 4 plus c. This problem's a little tricky because basically I have to break up the integral and break up the fraction into 2 different parts. So what I'm going to do is take the integral of 6x squared over x dx and add that to the integral of 1 over x dx. All that I did here was take the first part of the fraction over x, the second part of the fraction over x, and just split it by that plus sign like I'm allowed to do for other integrals. If I look at this first part, 6x squared over x reduces. It just becomes the integral of 6x dx plus the integral of 1 over x dx. When I integrate 6x, this becomes 6x squared divided by the new power 2. When I integrate 1 over x dx, this becomes the ln of the absolute value of x, and then I have a plus c. Technically, there was a plus c from this part and a plus c from this part, but I just combined them to make 1 over all c. Because again, we didn't know what the constant was here, we don't know what it is here, so if we combine 2 unknown constants, we just get a new unknown constant. Cleaning it up just a little bit, this 6 and this 2 reduce to give me 3x squared plus the ln of the absolute value of x plus c. This last one, part D, is definitely a little tricky. Basically, in this case, I have to make u the ln of x. So if I make u the ln of x, when I take the derivative, du equals 1 over x dx. So I'm trying to find 1 over x dx that I can replace with du. Good news. I can take this 2 out front. It's really a 1 over 2. So if I take that out front as a 1/2, I've left inside ln of x to the 8th. And then with this 2 gone, this is really 1 over x dx. So if I multiply this back through, ln of x to the 8th would be on top, 2 times x would be on bottom, and then I'd have a dx, exactly what I started with. So the way that I've broken this down is now I have what my u was to some power times its derivative. So I can replace this and make this 1/2 the integral of u to the 8th du. When I do u to the 8th, that integrates to u to the 9th, adding 1 to the power, divided by the new power 9, and really this is going to be multiplied by 1/2. Plus c, last step, 2 times 9 gives me 18 on bottom. U to the 9th is really ln x to the 9th, and I still have that plus c.